This is Masood.
Hello everybody, this is Omid. Welcome to our new session. Thanks for watching us and following us. If you remember previous session and sessions, we were working on a shop manager, yes?
Yeah,
That was
some
somehow
sort
shop
of.
manager. We were creating the product, customer, cart, and so on. We were making a menu, yes, actually. And I think we have covered up to number 2 or 3.
2, yeah.
2.
Yes.
This session, we are going to complete the menu up to, I don't know, maybe number 6. And if we can, maybe up to number 8.
Yes.
So it's better, I think, run the program, yes, to see what was the result.
Yes, why not?
And then we can continue the
From
rest
there.
of the program. Good.
Yes.
So explain it, please. What was the bet?
The
First of all, if you see, there is a menu, yes?
yes,
In our console.
the main function has
Mhm.
got only one line of code that is show main menu, and it's inside a while true that is an infinite loop.
Very good, yes.
And inside the show main menu, we've got this multi-line string, this syntax with 3 quotations, and then in this line here, we are asking for an entry from the user. Then after the user enters, it is waiting here for us to enter something. Then after the user enters something, inside some sort of a switch case, here in Kotlin is when structure, when class, if you will. There's when class.
That's the equivalent with switch case.
Yes, in switch case in other languages, it is good for replacing multiple if-else statements, sequential multiple if-else statements, and if very reads well, if you can see it's very well,
Very good.
better than if-else statements. And so far, as you said, we've covered these 2 first options: changing the shop name and creating new product. And so let's continue.
Yes,
from
exactly,
here.
yes. Go.
So let's just exit from the application. Here, number 2 is creating new customer. As I remember, we have not created any customer yet inside these lines. I think we just asked for the customer name once, just only once.
Yes.
And I don't see that here. Let me collapse all functions with Control Shift minus. So as customer name here, it is asking for customer name, and it is only storing it locally inside the scope, and it is not stored globally, persistently. The moment we call this function, after we call this function, this value will be gone. So we should store this.
This value.
Yes. What are the piece of the? Okay. Let's store this variable at the global scope, like the shop name, the customer name, and of course, as this menu indicates, the user should be able to create
A new customer.
multiple times. You know,
When he entered number 2.
yes, whenever he or she enters number 2, he should be able to create a completely new customer, and all the customers should be stored, like the products. So having just one single customer name variable of type string is not enough, and we should have a mutable list of
String.
string and customer names. So every time the function asks for, let's rename this function actually for create new customer, and ask for string from user, enter customer name, and get rid of this line. After the user enters the customer name, we
have to call that function we have written, huh?
No,
ask a read line.
We have not stored it in the list yet. First, we should store this customer name inside customer names. We should add it there to the end of the list. Now it is working. And the number 2 here would be create new customer function. So when the answer is 2, we will call this function. And
But nothing would print in command line, yes?
No. Why? It will print.
I mean, enter the new customer name.
No, it will show.
Oh.
It will prompt us to enter
Okay,
customer
yes,
name.
yes.
You go ahead and
Ask for customers.
no. You go ahead and write for this print customer list number 7.
I mean, you mean that I have to create a function?
Yes, you could do that. You could write the logic inside the scope of this case. For example, case number 7, and you could write a brace and write multiple lines of code there. But I prefer extracting the functions, writing dedicated functions.
I mean, I can here write print f. Oh, that's in Kotlin we have to start with fun.
Fun,
yes,
fun is for
fun.
keyword of
Printing. Yes, is that okay?
Yeah,
Printing the
customer
list or names.
Whatever.
You are the mentor.
Whatever.
List. Is that true?
Yes.
We should show what is the
return type.
yes or no.
Is there any return type?
No, we just need to
it is
print
just
something. Printing.
This function won't return anything. It will just print something.
So we need for or do while loops to iterate
we need some sort of loop, and I don't want
to see the customers list. Yes.
Yes. As you recall, the good and old for loop that you know that iterates over the list with an index of in is not here. We have for each loop here. For each. You could use that. You could use the for each loop. The for each loop iterates over a list.
I should write for each.
No. The for itself. And parentheses.
Sorry.
Write a parenthesis. For example, something in list. You name the handler that
like variable, like
yes.
I, you mean?
Yes, I in list, for example. Customer name in customer names, for example.
I should write customer name. And it
in
needs dot or no? In.
I think it is in, yes.
In customer.
I've not used this.
Customer names?
Names, yes. The customer names is the list that we want to iterate.
Yes.
Customer names. And it is working. I've not used it, to be honest. Yes.
Then we have to.
So let's first just describe the syntax. In other languages like Java, you, for example, see something like this: until I is less than, for example, customer names dot size. Please increment I every time at each iteration, and then do this here. But there is no need for this for loop here. It has many variants, and we will see that. This for each loop just simply iterates over the list completely one, but we can break from it at any time you want, but you cannot say, for example, please start from the second to the, for example, 1 to the end. It will every time
see whole list. Yes.
Yes, every time you have no option with this for each loop.
We can't use that for.
Nope.
From
nope.
In Kotlin. That's
no. There are other options, but I don't want you to get overwhelmed with the new syntax.
So we have to print. Yes.
Yes. Print what?
We done.
Semicolon.
Print the first we can say we have to print customer name.
Yes,
actually.
So the way it works is that at each iteration, this for loop assigns the next item inside this list to this customer name. So at each iteration inside this brace, you will have access to this customer name. Let's just change this customer name to CN, for example, because
yes, we have other.
Yes, because we had this customer name here, and the users, viewers may get deceived, confused that this has something to do with that one. No, this is a new variable. This is a new placeholder variable that will be field assigned with the next item inside this customer name list at each iteration, and we have access to the CN here.
Can we write, for example, customer? It doesn't need any one, yes, customer.
Nope.
And then CN, yes. You should add plus.
Plus, you could use plus. You could do other string interpolation. As you can see, there is an underline suggesting to do something. Convert concatenation, yes.
With $sign.
$sign. Yeah.
That's enough, I think. Yes,
yes, that's.
And we have to add it here to the.
Yes.
Then we add 7.
7, yes.
Then we add 7. What's that?
Printing the customer list.
Printing customer list.
Run the
Now
application.
we can run Shift F10.
Shift F10, yes. With option number 2, you will be adding some new customers, and then press 7 for printing the customer list.
So we have to wait. Number 2 first of all.
No, just wait. Click.
Number 2, enter the customer name, for example, Jack. Then
And again, the menu is printed again.
I could push 7, yes.
Yes. It printed, but customer Jack. Customer Jack. Just print something here. Print LN list of customers.
But what if our list is empty? Should we write another thing? Print anything, for example. Our list is empty. We should check something.
Yes, we could do
we
that.
Should check it in printing.
And before entering the for each loop, we could
we should check the size of the list.
check the size. Yes.
For example, if customer names.size is greater than 0, is not greater than 0.
Yes.
Print, for example, the list is empty or there is no customer.
You could do that. You want to?
Yes, why not? Here, yes.
Yes.
We should write if customer.
You have typo.
Yes, customer names.size less than 0. 0
less than 1.
Our list starts from 0 or what?
No. The size is the size. It is
less than 0.
Less than 1. If it is less than 1, it is empty.
Print ln.
Print what?
There is no customer.
There is no customer.
Is that correct?
Yes, and
what's that for?
No, this is a print ln after the print. So I wanted to add something like this as an indicator as the end of the printing. Yes. So there's something wrong here, and you've forgotten something. You have forgotten to do something here, and that would be
there
inside in this.
Even I need else?
No. There is no need for else. I mean, you could do this. This is one path, and executing these lines is the other path of this if. You could add an else statement and put these lines inside that else, but
that's not necessary.
Something like this. Else, if the size is not less than 0, then I want you to go ahead and do this. But you could do something other than this, like if the customer name is empty, print it is empty and return from here. Returning from function is feasible, is available from any line inside the function.
So what will happen if you don't write return?
If you don't write return, it will come here when the list.
Check the list is empty.
Yes,
there is no customer.
There is no customer. Then it will print list of customers. Then this for loop won't do anything because
I got understood.
You wanted to evade at the first place these lines.
Return is
avoid. Sorry, you wanted to avoid executing these lines. And because of that, you wrote this if statement. So you should write this return here, preventing it from continuing. So it is working, and I don't want to go to these one by one. I want to talk about something else here. We will complete this along the way. So each time we execute the application, we run the application, as you can see and you expect, if I press number 7 for printing the customer list, it will say there is no customer at the start. So the manager of the shop has to define the customer names and the product list and the whatever that he has to do. He has to do it at the start of the application each and every time. And this is bad. There is no mean of persistence here.
There's no memory.
There's yes. Everything is inside the volatile memory RAM, and the moment we exit from the application, it is all gone. But this is not the way the applications work, and it is not the way that people expect programs. They expect that the applications remember the last state. So we must add some mean of persistence to this. And so what is your suggestion here? Do you have any suggestions for adding persistence?
You mean that the next time we run the application, we could access the previous customers that we have?
We should continue from where we left off.
Actually, we can use. Can we use files?
Yes.
Textbox, for example.
Yes.
We can save them in a file.
Of course. The simplest form of persistence that we could use is file. There's no other any option. We could access some, for example, backend server endpoint and send these data each time to there, and at the beginning of the application, for example, ask for the stored data. But we don't want to do that now.
Actually, in Android, there is something called shared preferences.
The shared preferences inside the Android, if you've seen how it is implemented,
that's
actually
in XML. I think
it is an XML file. It is a file. It is actually a file.
They saved it in the file.
There's no any other way of persisting.
Yes, I have seen that. That's XML file.
Even the databases, SQL databases that for example, MySQL, or I don't. What is the
Room database?
No. The room is
SQL server
or whatever.
NoSQL.
Whatever you use, you may, for example, the viewers may say that go ahead and use MySQL, for example. Even those are using files internally. Even those are an application upon some files, and they are not doing some magic for persisting our state. They are actually using files, and we don't want to, get to this complicated stuff of connecting to the database and installing one and querying off of one.
Yes.
And we want to do it simplest form. We want to write our own
file,
yes, and store it.
Actually, I think I'm really afraid of files. I think there are lots of people like me that they're afraid of files and they think that's a great
The idea is very simple. The idea is very simple. Whenever you want to, keep it in mind. Whenever you want to do any kind of persistence, you have one and only one option. One and only one option, no other way.
Very good.
And that is storing it to a file or passing it to someone else and
to give it file.
To someone else.
Finally, it's a file.
Yes, it will ultimately will become a file.
So I should face with it.
Yes, face your fear. So, I'll write this function for persisting, that I want to call this function after show main menu is called every time. Every time the show main menu is called, the user of this application have done some modification to this application. For example, he might have changed the shop name or products, has created the product or new customer. Each and every time of the iteration of this loop, I want to store the whole persistence of this application, whatever it is. So, what is the state of where is the state of this application is stored at?
I think when we have entered the customer names and product state, we mean this.
Yes. I mean those things by telling
you mean where we should store it?
No, not where. First, I want to ask the question: what is the representation of our data here? Where is our data when the application is running?
You mean where we have stored it?
Yes, inside the memory. Where are those? What we should know? What are the things that we should store in order to make this application persistent?
Actually, I can't understand your question very well, but you mean that we have to store the names and the product names?
No, yes, store what?
Store what? You mean that where we should store it?
No, you answered it the first time. These I meant that these lines, these 4, 6, 7, 8, whatever, these global variables, values, lists, these are the state of our application. These are the data.
States. Now they're empty.
Yes. And no, we don't know that they are empty or not inside the app. At first, they are empty, yes. At first, when we run the application, they are empty. But these are the things that we are interested in. We want to store these and then restore it.
Yes, the list.
Yes, the list or the shop name or the customer or whatever they are. They may be some integers.
The highlighted part.
Yes. So I want to write this function store to persistence, and I want to add a brace body to this loop, and after the user
enter the data,
did
something.
did something, I want to store to persistence the whole application. The simplest form. So in this function we want to store our state to the persistence, but before doing that, because here we need to instantiate from the class of from the file class. We have to instantiate an object from some class, and we have not been introduced to class yet. And I want to talk a little about the class and what it is. But as I recall, we actually have used some some instance of class. These are actually the instance of the list class. For example, when we say, for example, here in the create single product, when we say something dot, this dot notation, add parentheses and this argument, this parameter we are passing, this is the function that we are calling. We are calling the add function, and we are passing this product price. But we are calling this add function on this object, upon this object. This product prices is a mutable list, is an object of the mutable list class. So there are, as you know, there are these primitive types in each and every programming languages. For example, this is an integer. This is a floating point number. True, the false are Boolean. Or for example, this is a char, a character, and single quote. With quotation, you write string, or with 3 quotations, you write multi-line string. Or what are the other types of the primitive?
These are the things that we use the most.
Yes, these are the things actually we use the most. There are some variants to this number. For example, this is an integer. If you assign it to something, for example, number, you will see that this will infer, and it is not working at the moment. This number is an integer actually. We could state it explicitly and not letting the Kotlin to infer the type. It is an integer, but there are some other variants to this to number. For example, we have long. We have long, or we have short, long, byte, and they differ in the size of them. For example, in the range that they cover. For example, in integer is from -2 billions, or I don't know, whatever, to positive 2 billion or something like that, and the long is a lot more than that. Byte is from -128 to positive, I think. Yeah, they differ in the range, and these are the primitive types that we use in every programming language, and these are actually an object here in Kotlin. So, for example, to prove that this is an object of integer class, if you press dot after it, to prove that, you will see that this is the list of the suggestions that it is showing us. These are the functions that we can use on this object of integer. For example, we can do what?
Divide, huh?
Yeah, we could do what? For example, divide with other integer. For example, divide to 10, or something like that. These functions are actually defined inside the integer class, and all of these are integers. So, it is not like the Java that these primitive types are, for example, in Java we have the type of char, and we have for example, the type of integer with lowercase I, and we say that this integer with lowercase I is primitive, and we have this with the low uppercase I, the integer in the Android. Yes, and we call them the wrapper classes. You've came across them. Yes, you've seen them. Those are the wrapper classes, and these two variants make it very ugly working with inside Java, and the Kotlin
yes, it's confusing.
has learned the lessons, these lessons, and in Kotlin there is no primitive type. In Kotlin they say everything is an object. Everything is an object. True is an object of the Boolean class, or this A is an object of char. So to prove that, we can say ch is type of. Let me just let it know it doesn't infer. This doesn't show the inference. It is of type character. No, sorry, char in Kotlin, and the char is actually a class. It doesn't help me here. Cannot show declaration. I wanted to show you the declaration of the class, and we could call functions on this char. These are the functions that are defined inside this char class, and I don't want to go into details of polymorphism or encapsulation or those jargons around the object-oriented programming, but I want to just simply introduce you guys with the concept of class, just from the point of a kind of structure for composing and grouping a bunch of other variables into one. So as I remember, we used to store our products into multiple lists here, and each product has some pieces of information dedicated to it. For example, each product has a name, has a price. It may have, for example, how many left inside the inventory or whatever. But if we want to only store them with the aid of these lists, we have to write a new list, and for example have a protocol that each index at each of these lists has got a piece of information about for example specific product, and this information is distributed among these lists, and it is not good. It makes working with the information very hard, and we want to group them into a single class. We want to say it would be very nice if the Kotlin had for example the type of product at the first place, and we could instantiate an object from it and store its own price and name and other properties inside it. And we want to create that type here. We want to create the new type. So these were the our pre-built, if you will, the primitive types that
we are going to make our own.
We are going to make our own type,
whatever we like.
And for that, we are going to use the keyword class. So we are going to define a template for a structure. For example, the product structure is composed from a product name, which is a string, a product price, which is integer, or other things. This should be a structure for itself, on itself. And we want to define this structure. For defining a structure, it is like I'm using classes here like the keyword struct in C programming language. C programming language is not OOP. It is not OOP at all. It has no concepts of object-oriented programming inside it, but it has the struct keyword that is used to group a bunch of variables into one. So we say we are defining a new template, and we name this template product. And This is the body of this structure. And we say, for example, each product should have a product name, which should be a string, and it should have a price that should be an integer. So let me just change the name to the name. There is no need to say product name, product price here. Yes, because inside the context of the product, it is actually, it is obvious that the name is the name of the product and the price is we don't have to state it over and over that it is the product name or the product price. And so let me just make them var to avoid the initial complexity, because it is telling that we should have some initialization value. So this product here is actually a template that we want to make instances off of it. We want to make multiple instances of this product. So to do that, so let me have this constructor. Let me put it this way. Define this constructor function, and each class should have a constructor function inside it. A constructor function is a special kind of function that is written this way, constructor. And this is used for initializing the primary initialization of this, for example, class object at the start. And we should write it. We should write it inside.
That is necessary?
That is not necessary. If we don't write it, it will put an empty constructor function with an empty body.
Default constructor.
Yeah, and this is called the default constructor. But I want to write it explicitly here for you guys to see that this is a function actually. This is a special form of function. So what we have here is a template of product. This is our template. We want to.
We are going to use it more.
Use it here. We want to replace these two lists with a list of product. You go ahead and do that.
Me?
Yes.
What should we do?
We want to write a product list. So for the moment, just let these lines these two lines to just stay where they are, and write a new list, which is a list of products, and we want to go through the application and replace the usage of those.
Write a new variable, yes?
Yes.
Variable product.
Right with the lowercase p. Products. Product list, whatever it is, product list.
Product list.
Yes.
You should assign it with like that?
Yes.
In Java, it's different, yes?
It's different here.
In Java, I read like that.
No. It will infer it. It will infer it.
Product.
No, it will infer it.
So then here I should write equal.
Mutable list of.
Mutable list of.
Mutable list of. Mutable
Here,
list of what?
Here I should write product.
Yes. It is the mutable list of product.
That's product list.
Product, yes. And just ignore these angle brackets for the moment.
You mean clean it?
No. Don't
think about it.
Yes. Just ignore it. It reads for itself. It says what it is doing. But these are actually the generics. Yeah, we will be introduced to them along the project. Just ignore them. So this is not the object. This is not the instance. We have not instantiate or create an object yet. But we have created a template for creating objects of it, and we have defined this list which will hold instances of this product here. So go ahead, continue.
So what should I do then?
And in creating single product, I think.
You mean that if I write product?
No. It is perfect.
Dots and so.
It is perfect. You cannot write it here. It is perfect now. Just go.
I mean that if I write here, okay, product list dot.
No. You cannot do that. In the create single product, as you can see, we have used these two lists to store the name and the price.
Yes. Here I should use that. Okay.
But we want to replace that. We want to first create a product and assign that product to the list.
You mean that I should write here? Name of that was product.
Product. Yes. in order to instantiate from a class, you have to do what?
In Java, I read like that.
Okay, write your Java
Messy.
syntax, product, and parentheses.
That was in Java.
This is in Java, but
Semicolon.
in Kotlin, as I said before, stating the type is comes after the name itself. For example, in Java, you say that this function is returning a string here. It is returning a string. But in Kotlin, you should state it here. It is returning a string. In Java, you say it is taking a string argument, for example, the name. But in Kotlin, you should say that it is the name is type of a string. You should state it after the name.
So I should write product and then.
Yes.
You mean that here I should write product.
Product.
Take a bit small one. Product. Then dot colon.
Colon. Yes. Of type product equals
new product.
And in Kotlin, there is no need for this new. We are actually calling a function. You know, the parentheses say that we are calling a function, and we need a val or var at the beginning to tell us that this product will be changed or it won't be changed.
I think it will change.
No, it won't change. It won't change. Yeah, we will add this product to the list. Just get rid of that line, and this is a val. And let me just make it clear here that what this line is doing. We are calling the constructor inside this product. You know, it may be better if the syntax would be something like this. For example, constructor. For example, if we call this constructor function on this product to create a new instance of it, but there is no need for this. Actually, when we call a function after this product, after the name of the class, we are actually calling the constructor of it.
So I think that here, instead of this line,
yes.
I should write product dot name.
Yes.
Should I write dot or no?
No. Product name equals
equals product name.
Product name. Yes, of course. And
you should get rid of this line. Yes.
Yes. Just let it be for the moment.
Then product dot price equals product
price. And let's comment this out. So as you can see, this product is in a structure now that defines the boundary of a product. You know, these information belongs to a specific product. So they should be grouped and they should be stored together. They should be accessible together. We should not go, for example, over some lists of information. You should not distribute the information to multiple lists and go over them to find, for example, a piece of information about a single and specific product. And this way we are...
In the constructor, we should pass it or no?
No, we don't want to use the constructor for now. We just want to, define and show that product here, this class notation here, just helps us to group a bunch of information about something.
They are related together.
Yes, they are related together, and we can instantiate and create as many as objects as we want, There is no, limitation. So I think with that, we can, finish this session. In this session, it was pretty much, maybe it was pretty much heavy. If you've not seen this
previous sessions.
No, not the previous sessions. This product, this product structure for the first. If it is your first time seeing something such as this, the product, the class, it is. I know that it is a lot to comprehend at the start, but it will make sense, as I said before. It will make sense more along the way. We will create hundreds of classes along the way of writing this application, and you will be very comfortable without noticing. So just follow, just continue, and
don't afraid.
Yes, just don't be afraid. Don't say that I've heard about, for example, public, private, or these access modifiers, or about polymorphism or encapsulation.
You will learn all of them during this course.
Yes, or the constructor functions, or other things around the class topic, you will be introduced to them. And we will be introduced to them when we need them. We don't need them here. We don't need them now. We don't need X modifiers here. Actually, we just need some structure to group.
When we need something, we will teach it.
Yes, that's the best way.
Good. Thank you for watching and following us.
Thank you.
Bye bye, guys.